these are the zeros of the function. The bottom, these are the asymptotes of the functions. So I'm just going to put A for asymptote and then a Z for 0. Okay? Gotcha. So we know it's 3, -5, and -1. So we're going to make our graph. I'm going to change color. Christmas. So, what was that?
Where are you going?
I don't know.
0? You just told me what it was.
What?
Start from 0.
Okay.
Then go to -1, then -5.
This is -5.
Yeah. And then do so those are your zeros. So put your dots there, because they're zeros. It's a little bit off calibration today. But you're not back on marker, though. Would you like that?
Yep. 0. 0. Okay, now let's do the asymptotes. Yeah. So 7, -1. Whoa.
Whoa, that was that last problem.
Yeah.
Oh my goodness.
So we have a 0 and an asymptote on the same thing. So that's going to end up being, as we learned, a hole in our graph. She gave you a complicated.
I got it.
She gave you a complicated one really quickly. She's kind of mean today. That's -2. I already did 7 and -1. So that's it.
What about -2? What about this x that's over here by itself? Did you set that one equal to 0? You set everything else equal to 0.
Yeah, so it's 0.
So it's 0. There's an asymptote at 0.
We haven't done that yet. That's new.
I'm sorry. We did one where it was a 0 at 0.
So now we have to find if it's positive or negative each section. So we're gonna plug in -6.
Sure.
So -6 minus 3 is
Negative. Positive or negative?
It's negative. So the top's negative and then negative. Positive.
No, -6
No,
minus 7.
that's still negative. My bad. Negative again.
What about this negative? Don't forget about that x. -6, you plugged in a negative.
-6 is negative. So negative over negative equals.
What?
No, negative over a positive.
Oh, wait. Yeah.
Because you got 4 now
You're
on the bottom. It's going to be what?
So it's negative.
Negative.
So we know that this right here, can I just look right is negative. This is what then?
So we figured out yesterday.
Positive.
Pretty much
This is
alternate.
hard. How do you do this every
It's
day?
negative.
What is on this side of
So
the
if we plug
-5?
in -3.
On
and
the
then-
right side of the -5 is positive. And on the left side is negative.
Can I
Does
just
it alternate? Negative.
But this is tricking me up.
Yeah, what happened when there was a hole in it?
It just stayed the same.
It
So
stayed the
this
same.
is all negative.
So it's all going to be negative. What happened at 7? You didn't draw your asymptote at 7.
So I put positive on the side. So it's gonna do something like this.
Jump. It's going to have a
Hole.
It's going to go back down. We don't know exactly where up or down it is. We don't.
Oh, I did so good. It was the same thing.
No, it's positive.
Yay!
Wait, so close till the end. When it jumps across this asymptote, it's going down to negative infinity. What's happening over on the other
Oh, it's going up to negative.
It's coming down this way. It's just never gonna cross back over the
Okay, yeah,
x-axis.
you get it. That was really sloppy and also very hard to teach.
It's okay. This is going up to the asymptote.
Yeah.
As we approach
Does that make
asymptote,
sense?
we're always going either positive infinity or negative infinity.
So in this class, she says that it's always alternating, but apparently that's not always going to work.
Then we will get to a point where we'll have a parentheses that will have a squared on it at some point in time.
Will
That
it be a
will
while?
change.
Can we just assume this for a while?
We're gonna assume this the rest of this quarter. How about that?
Okay.
The whole week and a half we have
Yours
left.
was a lot prettier than mine. But you had
So why does it like? Why does that graph on the right? Like, why does it do that?
What, this one? Okay, so from here we see it's gonna go all the way. It jumps across. It's coming up from positive infinity. But the issue is there's no more zeros.
Okay.
So it will
So it
never
can't
cross
okay.
the x-axis again. We don't really know what it's gonna do. Yesterday we kind of did a squiggle because that's just like to the left of -5. We know that's a 0, but we don't know what happens afterward. It's never going to another asymptote. It's never coming back up through the x-axis. So we just kind of draw squiggle lines. It's up to you. Okay? But it will go on that way forever. Some of them will come and ride the x-axis. Some of them will come down and go back up.
And so on the -1 where it hits the asymptote, that's just like a hole.
That will be a hole. I'm going to erase the because it won't be a 0 there.
It's
Because ultimately, when you see this, we think, hey, I can cancel it out. But really, it's still in there at the beginning. So if we had put in a -1, we wouldn't have got an output. But you end up somewhere with a hole. The one we did yesterday, it was between an asymptote and a 0, and we just left it with a hole because it was positive.
Gotcha.
So it just ended up being a hole in the middle. And then went on somewhere else.
I see the circle.
The squiggles became kind of, yes. Okay. A little bit.
We almost use the same color.
Almost just the same colors. Green and blue. You started Christmas with the red. Then you went to green to blue.
Okay, Molly.
Blue is kind of a Christmas color.
It's a
Blue and
winter-
silver
it's
is a winter color.
Haunted color. We have to,
Spring color. Did you know that red and white are officially colors of Christmas?
No.
I'm gonna pretend I didn't actually hear you. But okay. It's not in my house. I don't know. It's not in my house.
What's it at your house?
Red and green.
Oh yeah, that's most people's house.
Wait, what did you say?
She said red and white
I
are
think,
officially the
you know, we
Christmas
did
colors.
those trivia questions at church at the Christmas party. It was like, what are the actual official colors of Christmas? I think it was like red and white. But I could be wrong. It was multiple choice and I don't remember the other one, so it might be red and green. Why is it red and green? The Christmas trees.
But in my house it's always red and green.
I mean,
And
Santa-
those are also Fuller's birthday colors too.
You have
2 days
birthday
after.
colors?
Yep. And it's 2 days after Christmas. He kind of just has Christmas. So he like officially says red and green. But he loves Christmas. And then, what?
I was close.
So if I asked you to find the limit as x approaches 0, so now we're looking at limits as we're approaching asymptote. Oh, is there an asymptote?
Yeah.
Where? As x equals 0, correct? So if we look at the graph of this,
We did this before.
we have definitely done this before. We're just going to look at it a little differently now.
Ooh, I like it.
Okay? So if we were graphing the top, are there any zeros? No. Is there any asymptotes in the denominator?
This asymptote
Yes.
is 0.
At 0, yes?
Yes.
At 0. So what happens? So there's no zeros, we've said. There's one asymptote. what is happening as x is approaching 0?
It would be this and
Okay, so we would look to the left of the asymptote if we were to plug in -1. What happens?
down.
Plug in -1, it's negative. What do we know about things that are approaching? So technically we could actually find the number, -1, we're at -1. Okay? If I plugged in a fraction, a -2. Sorry, I just said fraction and
-2.
-2. Okay.
Negative half.
So what if I plugged in, instead of plugging in -1/2, and then when you do the reciprocal, what do you get? -2. So that's, I'm thinking the answer is already -2. Alright, so if we plug in -1/2, we get -2. If we plugged in a third, we would get 3, right? If we plugged in -2, we would get -1/2. So we see we're approaching our asymptote. We are approaching the 0, but we're never crossing it. Okay. On the right side of the asymptote, at +1, are we positive or are we negative? Yeah, +1. At 1/2, we're at 2. 3 here. At +2, we're at 1/2. So if I were to ask you the question, what is the limit as x approaches 0 of 1/x? What would you say?
Well, from the left, it is negative.
Right, and then from the right,
Positive.
positive infinity. So does the limit exist? We would say the limit does not exist. Okay? You check the left-hand limit, you check the right-hand limit. If they do not equal, then the limit does not exist. Okay? If we were to plug in, we do several. What happens if we plugged in? Okay, I'm going to forget this number. The limit as x approaches 0 of 4x plus 8 over x plus 2.
You want me to do something?
I don't know. What are you doing?
Foil.
Okay, foil. How are you going to foil?
Hey, you know what it will equal?
I do. How'd you get that?
Because you foil and cancel it, foil. So it would be foil. So
I
plug
mean,
in zero
you
because
can
you
just
can
plug
add
in
it
zero.
too.
So
But you
why?
can't do
What's the first thing we should always, every time, always,
Try and plug
first
it in.
up,
Try to plug
plug
it
it
in.
in.
And it works this time because the
If
bottom.
we
It never works.
plug it
You get
in,
this one that works, Miss Evans.
0 plus
Look at
8
you.
over 0 plus 2 is 8
4.
over 2, which is 4.
See? 4.
Okay?
That just
So first thing you need to look at is plug it in. Okay? Plug it in, and if it doesn't work, like the first one,
Was undefined.
it's undefined. So sometimes they'll be undefined. What happens with limit?
We go back to the same thing.
Limit as x approaches 3 of x squared minus 9 over x minus 3.
Oh no, it's nice.
It's
gonna
going
be
to
x
x
minus
minus 3.
It would be just x minus.
So
It's
we try to
0.
plug it in. So when you plug it in, Justin, what happened?
Well, it's 9 minus 9.
9 minus 9
And 3 minus
3 minus 3. 0 divided by 0. Is 0 divided by 0? 0.
Yes.
No.
It's 1.
Anytime you have a 0 in the denominator, it's undefined.
Even if it's
Even if it's going to be
But it
zero.
is.
Whoa.
Look at this, Miss Evans. Look at
But it will not be 0.
Technically, 0 times anything is 0, though.
But this is not a thing.
But
Can it
is
be
there anything
infinity?
you can do?
If you make it x plus 3 and
So-
x minus 3.
You have a difference of squares that you can factor.
6.
Now, granted, what's going to happen at these things? Okay, what did we just do with our graphs? What did we just do with our graphs?
That would be empty.
Will there be a hole at x equals 3?
Oh, I know why y'all
Yes.
Oh, yeah.
But this is what
That's
it's
why.
approaching.
This is what it's approaching. Okay, so here we go. We have
Wait,
a
are you
negative
recording?
3. So the 0 at negative 3 is 0 at positive 3, but there's also that asymptote at positive 3, right?
Yep.
Okay. So what happens to the left of negative 3? Negative and a negative and a negative.
They-
I'm pretty sure it's going to be negative, yes? To the left of negative 3.
Oh, we're doing this. Never mind.
I'm kind of combining two things.
That would be a whole.
Between negative 3 and our next piece, which is a positive 3, you plug in 0. You have positive, negative, negative, which is going to be positive. After 3, you technically have 9 times 0 divided by 0, right? But is it positive? Because ultimately, what we really want to do is cancel those out.
And then use 3 plus 3 is 6.
Would it still be a positive? Did I say 9? I think I said 9. Sorry.
Yes.
So this graph, we're coming from below through 0. We're positive. Who knows what's happening? But at somewhere over here at 3, where we've got another asymptote. Who knows what's happening? But it's negative over here. It's positive over there. We've got a hole.
It looks so funny.
But what's happening? What's it approaching as we come to that hole? Meaning, if we were to plug a 3 in,
approaching to 6.
it's approaching 6. Is it approaching 6 from the right side and the left side? Yes.
Yes.
It didn't
Yes, it is.
change.
It didn't change.
It didn't change anything. We could have gone back and plugged in 2.9, 2.99, 3.1, 3.01, 3 point. We could have put it.
1, 4, 1, 5, 9.
We could have plugged in those.
Well, it hit 6.
Will it ever hit 6? No, it will not.
It's approaching to 6.
It's approaching 6 from the left and the right. There's just a hole in it.
Okay.
Okay?
And it'll never hit 3.
It will never hit a positive 3. At 3, there's a hole in it. Yeah? Alright, so what happens if I say what's the limit as h approaches 0 of? Let's see. That's not where I'm going to put that parentheses. It doesn't matter. Oh. All of a sudden, I kind of bumped it up a little bit.
You went from like
Should we
0,
do
and then we went to like 2 miles an hour, and then like 15 in the school zone, and then boom, interstate.
Interstate.
There was no like.
Interstate in
Garden or-
Texas.
Memorial going
Yeah.
down
We didn't even get like
Broad Street,
highway,
45 miles an
highways.
hour.
No, we just
Texas
went
highway.
straight to interstate.
80 miles an hour.
Okay.
This may be the Autobahn.
So I'm gonna plug 0 into H here.
What happens when you plug 0 into H?
You get sine pi over 2, which is
No. That's really just
45 degrees.
no. That's pi over 4. Oh, 90.
90.
So it's
Okay. The
99
biggest thing with this is looking at it.
It's
Do you recognize
isn't it cosine something?
something with this equation?
It's
Well, regardless,
Cosine H.
it's sine pi over 2 minus sine pi over
Cosecant H.
Oh.
You were better the first time. Okay.
Can you
Well,
well,
I heard-
and then subtract a sign? Like,
Okay.
can you do that?
90.
No. Oh, true.
Okay. If we have sine A minus B, going back a long time,
Equals.
you cannot distribute that.
Look,
Sine-
It would be
sine
cosine
90
B.
is 1.
Okay.
1 minus 1,
Is 0.
0, over 0.
Same scenario we just had.
Yeah.
Is that possible?
No.
No. Let's look a little harder at what is the format of this problem.
It's cosine something.
Okay, but why? What is it? What? Go backwards.
Because sine a 90 minus a equals cosine.
It's
A.
cofunction.
I remember we did that before.
Cosecant A.
No. Or
What happens? Let's look at another one. Limit as h approaches 0 of sine x minus h. Would that help if there wasn't a pi over 2 in it? Do you recognize something going on? What? Would it help?
ooh, Savannah said.
I didn't hear what she said.
Definition.
Is it the definition of a derivative? Would it help
Wow.
if I put a delta x?
And by you need to change the sign, like, cause that's supposed to be plus.
Right?
Oh, it is plus. X plus h.
Oh,
Yeah,
yeah.
no.
I put it up there. I'm sorry. Sorry. I messed you all up. I was going with the second piece.
Not everything makes sense.
Oh, so sorry.
Oh, it's a derivative.
So this is the format of the definition of a derivative. What are they asking for the derivative of? What are they asking for the derivative of in this second problem? What is your f of x? So this is really f prime of x. Can you go back and find what is f of x? So what is your f of x? Does everyone agree? The second piece is always going to be your f of x. Look there. Do you know the derivative of sine x?
Yes, we do.
Yes. Yes, you do. It's cosine x. So if you know the function, what is the derivative of that function? Okay. The first one up here. What do you think they're asking for in the top problem? What's your f of x? What is the, did it give you a specific x?
Yes. Sine pi over 2.
So in this problem, this is f prime of pi over 2. Okay? So what's the derivative? And then plug in the x. So the derivative is what? What's the derivative of sine? Cosine, and then guess what we're plugging in?
Oh.
Pi over 2.
Miss Evans. That's I think the answer.
What is the answer?
Cosine of pi over 2.
No, that's not the final
Oh.
answer. What is
It
cosine pi over 2?
Square root of 3.
What?
It's 1.
0.
It's 1 over half.
No, look at the back. It's 90 degrees.
It's
One.
The right side at the top is 0.
Oh.
So the answer for this first problem in green is 0.
It's a good brand estimate.
That's a lot of work to do.
I know it is a lot of work to get
But it
0.
really actually wasn't a lot of work. It was just confusingness.
It was recognizing it.
You need to be
Going through.
You need to be very thoughtful.
In your book, they specify the ability to recognize limit problems that are derivatives in disguise is a critical skill. They appear in virtually all standardized calculus tests. Variations of the following limit problems appear in several future problem sets. Look for them. So what if we have the limit as h approaches 0 of natural log x plus h minus natural log x all over h.
But you say the derivative of sine is cosine, and the derivative of cosine is 1 over sine.
No.
Negative sine.
Negative.
So we're trying to find the derivative.
So I want you just to answer this problem. So is this still in the derivative? What is your f of x?
It's a
That's
natural,
the biggest question.
natural log.
What is f of x?
It's natural.
Did we all answer that question? Natural log.
And the derivative of natural log
So what is f prime of x? What's the derivative of natural log x?
What is x?
Is it 1 over x?
Oh, it's 1 over x.
Yeah.
But which one is never changed? Like,
Well, I don't know. We'll see. Can I do one that said, what's the limit as h approaches 0 of e to the x plus h minus e to the x all over h? Hey, let me give you this. Are you coming back?
I'll come back to get
Okay.
this stuff and give you a.
Okay.
That's fine.
I thought e to the x
So-
equals natural. Oh, they're different. I'm
They're
sorry.
completely different. We did them on the same day, but they are completely different.
Alright, so natural log.
So, what is this? When I see limit, when I see a plus h, I'm going to say, what is f of x? Question mark. Can you answer that? Where is f of x always going to be in the definition of a derivative?
In the second term.
In that second piece. It was right here. It's going to be that second piece. Minus f of x. So e to the x is our f of x. So what is the derivative of our f of x? What's the derivative of e to the x, Justin?
1, 0, e to the x.
E to the x.
Yes. E to the x.
Derivative of e to the
No,
x is
I hate that one.
why? It's the same number.
If Justin wrote like 47 terms of it one time.
Yeah, exactly.
I'm sorry. Okay, these will show up.
And it's like cosine is negative side. I need to write it down. I was,
Cosine what?
Derivative of cosine x.
What?
Yes.
Taylor?
Yes.
What are they?
We're gonna have a few problems for homework that will be due Thursday.
Thursday.
Thank you.
That's nice.
Can you remind me to do that on Wednesday?
No.
Please.
We're gonna do one. We're gonna do 1 through 8.
Are they all limits?
No. We're gonna do 15.
15.
Ooh, I should give you that one, but we won't.
That's what
I think this is
I don't think your flight ready for the issues you could be. It would be a good leading question, something we're gonna do.
It'll be alright.
It'll be alright. Alright, just these. So we can start 1 through 8 and 15.
Thank you so much.
You're so welcome. So we got some homework problems before you were gone.
Just those,
I wanted to add one more, but you talked me out of it. I talked myself out of it. Do we need to look at number 1 together to start? You gonna do that word problem?
It's just that I just need to find that formula.
What's the formula?
is supposed to AT and then A0 and then E and then T times K.
Yes, that's a very important formula for number 1.
Oh yes.
Decreasing at an exponential rate. The treasury contained $2 million on the first month, on the first of the month, and contained only $100 on the 13th of the month. In which day does the treasury contain $500,000? So you're solving. What are you solving for?
For the
Time.
Time. You're solving for the t. You're not plugging in a t this time.
this time different.
This time is a little different. So what's our initial amount?
Initial amount will be
2 million.
2 million.
And it took 13. The initial time is 13.
The initial time, or we're plugging in the amount at time 13. That's what this is asking. So what's the amount on the 13th? What's
No,
that?
this is saying what amount was at 0.5 million. So first you have to solve for K.
So we have to solve for K first.
And it gives
Yes.
you your time for the
So,
so the A of T is 100.
It's 100.
And then you do E, the time is 13, and then you have to solve for the K.
I'm gonna ask a question. The 2 million on the first day, and then on the 13th day
Was 100.
was 100. Is that 13 days or 12 days? It's the biggest
Well, it's
question.
just it's at the first of I don't know.
This is 30th.
It says 30th, not 13th.
Oh wow, we're
We
great at reading.
all read that wrong.
We're great at reading.
Okay, so next question. Thank you, Molly, for reading closely, because we all would have gotten the entire thing wrong. So on the 30th of the month, so the first of the month to the 30th of the month, how many days is that?
31. 30.
It definitely is not 31.
30 days.
I'm debating between 29 and 30.
Well, because if you start at the beginning of day 1 and the end of day 30.
The
that's
first
30
day,
days.
first day to 30 days.
30 days. First day to 30 days. So 30 days.
All right. So
It's 29 days.
How come?
did you count?
Yes.
1, 2, 3, 4, 5.
29 days later.
Well, it's kind of like it's just that's always such a weird.
It
like,
is.
You can't.
Like from 1
Oh,
to
it's
8.
29
How many
days.
problems is that? Is that 8?
Is this Central Eastern Time?
1, 2. Is it what time zone are we in?
But you say the first day to the third day would be 2 days because 1 to
So from the first day to the second day.
2 days. First day and second day.
We'll do it.
No, I don't know how you count
doing 30.
We're either all gonna get it right or all get it wrong.
Come on, tell me the right
I
answer.
feel like it's gonna be 29.
I'm pretty sure it is.
I just don't get it. Okay,
But
let's
if
do
we're all doing
29.
30, then you won't count it.
If we all have the exact same answer.
Well, I'm gonna do 29.
You'll be clear.
Tyler's gonna do 29
I'm
now.
doing
I feel like
29.
it would be right.
It is.
It's just such a weird concept.
You start at time 0.
Are we doing 29 now? Oh, I'm a Reagan kid.
How are you ready? Alright, classes got done. But
Sick.
we would solve, divide.
So it's settled. We're doing 29.
We are doing 29.
But Miss Evans, can you teach me how to count? I don't know how to count.
Alright.
From the first day to the second day, it's 30